In a regular ISO-OSI stack for Internet applications, the transport layer is located between the media and application layers, precisely in the middle of the stack. It is sometimes referred to as a part of the host layer protocols. The transport layer is responsible for end-to-end communication and provides segmentation and aggregation mechanisms, error detection and correction, flow control, port-based addressing, and quality of services. In the case of the Internet and some Internet of Things network stacks, the transport layer has two major protocols, TCP and UDP. TCP is the connection-oriented mode. The connection between endpoints is kept open for the whole transmission time, and it is possible to detect connection breaks and interferences. TCP ensures delivery over the network. You can imagine that TCP as similar to making a phone call. While you are connected, you can hear your friend's speech in real time, breathing, and background noises to tell the connection is not dropped. A dropped connection can be sensed, example by the termination signal, or simply when there is no silence and no replies from the other side. Similarly, in TCP, when there is no acknowledgement for a specific timeout or after some retries, the connection is considered dropped. This way, both endpoints are aware of the state of the connection and can ensure the quality of service. Typical high-level protocols using TCP are HTTP, SSH, FTP, and many others. On the other hand, UDP is connectionless, in which the sender sends the message and it's not guaranteed to be delivered. Moreover, because of the routed nature of the connections, consecutively sent messages may be delivered partially, unordered, not delivered at all, or even appear duplicated. Error checking and correction and quality of service in UDP are implemented in higher layers of the communication stack, usually in the application layer, if only needed. The UDP protocol can be imagined working similarly to SMSs on your mobile phones. To send the message to your friend, but there is no explicit reply, you actually never know if your friend got a message. Just send and forget. Acknowledgement of the message is handled on higher level, example, when your friend calls you back or sends you a reply message. UDP is lightweight and therefore is typical for video streaming, example, video conferencing. It's suitable when it is acceptable to lose some of the messages, example, in multimedia streaming. In IP networks, the choice between UDP and TCP is usually driven by other stack layers and required protocols. For example, MQTT requires TCP and COAP works on UDP. A rule of thumb is that many IoT networks use UDP or UDP-like transport models over TCP, even if the network is unreliable. UDP is lightweight compared to TCP and is common choice for IoT networks, particularly those connecting end-node edge-class devices, because of the constrained resources in IoT devices. UDP is also more energy efficient. Some IoT protocols, such as ZigBee, present their own implementation of the transport layer. Layers are merged with other layers, commonly the network layer and higher application level layers as presented in the figure.